Hello all. In today's session, we will talk about the practical application of a single unit perceptron for classification problem, which is the first experiment of your lab. Design single unit perceptron for classification of iris dataset without using predefined models. So the dataset what you are using here, iris dataset, this is the dataset what I have used in this experiment. So these are the libraries which I have imported. This is the path for the iris dataset. So the first step involved here is loading of the dataset. I have loaded the from sklearn.datasets. I have imported load iris and train test split also. This will import the train test split function from scikit-learn and this load iris function from the scikit-learn. To find the variables in the given data set, I have used a data frame called as iris and this is the output. You can see that I have 150 rows and 5 columns here. So that means I have 4 input variables x1, x2, x3, x4, sepal length, sepal width, petal length and petal width, and species is the target variable. Under species, how many categories I have, I can find using unique variable, unique function. So iris of species dot unique will give you the type of class labels present in that species target. So I have setosa, versicolor and virginica. That is, given the 4 input variables x1, x2, x3 and x4, I would like my model to classify that given species under setosa, versicolor or virginica. So this is the scatter plot what I have drawn, taking only 2 variables, that is sepal length and sepal width, on x and y axis respectively. So throughout the experiment, I will be using only these 2 variables as x1 and x2. Based on these sepal length and sepal width, I would like my machine to classify that given species as setosa or versicolor. So in the labels also, I have used only 2 labels. You can use all the 3 labels and you can use all 4 input features also. And to know the size of the species target variable, setosa 50 out of 150, 50 rows belong to setosa, 50 versicolor and 50 virginica. And among all these 4 input variables and 3 target variables, I will be using only 2 features for X and 2 classes for Y, and using only 100 rows. Out of 150, I am using 100 rows. Out of 4 input features, I am using only 2, and those 2 are sepal length and sepal width. And the target class label what I am using is setosa and versicolor. So as I am using setosa, versicolor as my class labels under Y, obviously for setosa it will take 0 and for versicolor it will take as 1. But our perceptron model will work better with the labels of 1 and minus 1. So I'll change the labels 0 and 1 to minus 1 and 1. So I'll change the label of 0 using np.where_y, that is wherever y is equal to 0, replace it with minus 1. 1 is as it is. So wherever minus 1 output represents setosa and 1 output represents versicolor. This was the first step. Second step involved is splitting the data set into testing and training. So the tester side what I have used here is 20% and the remaining 80% will be used for training. The random state is 42, which will ensure that the split what I have done is reproducible. Under this splitting the data set, I will initialize the weights and biases also. So weight is initialized with 0 using np.zeros and bias with 0, learning rate 0.1 and epochs as 10. These are all the parameters which we have done in our theory sessions. Learning rate I have taken it as 0.1 here. It will control how much the weights and biases are to be updated during the training process. And epochs I have taken as 10, that is the number of iterations I would like my machine to perform is 10. Second step is done. Third step, I am performing perceptron training. So I will be taking starting with a loop over the number of epochs using for loop, and each epoch will represent one full pass through the training data. And here I'll start the loop over each training example for I in the range of x underscore train dot shape. linear output. This is nothing but y is equal to wx plus b. So this y is equal to wx plus b is given as input to the activation function, and this is the predicted value using the activation function called as linear output. That means when the output is greater than 0, the prediction is 1, and when the output is less than 0, prediction is -1. So -1 prediction is for setosa and 1 prediction is for versicolor. And if the error is more, then I would like to update the weight also. So if training predicted values and the true values are not equal, then these are the formulas to update the weight and biases. So I'll update the weight as W plus eta YIXI and update the bias as bias plus eta YI. So this is, as we are making use of a perceptron, it uses a straightforward rule for updating the weights and biases based on the prediction error. Whereas in gradient descent, we have learnt that it will update W and B by using the partial derivative. That is, W nu is equal to W old minus eta times of dou L by dou W, and B nu is equal to B old minus eta times of dou L by dou B. That is for gradient descent. As we are using a simple perceptron model, these are the formulas to update the weights and biases. Now, once I have trained my machine, I would like to test whether it has classified accurately or not. For that, I will test the perceptron. So, initially, I will initialize a counter so that I'll keep a track of how many labels are correctly predicted. And then I'll start a loop here for I in the range. This will start for on each test sample. I will have a loop. I will start the loop here. And this y is equal to mx wx plus b will calculate the linear combination of input features, weights along with the bias. And this is my predicted value, which will apply the activation function to the linear output. And if it will check this, if y predict is equal to y test, it will check whether the predicted label matches with the actual label or not. If the prediction is correct, then the counter will be incremented. And at the end, whether the classification is done accurately or not, whether the labels are matching properly with the actual value or not, can be found by using this parameter called as accuracy. So I'll calculate the accuracy, which will calculate as the ratio of correct predictions to the total number of test samples. And I got the accuracy as 100% here. So this is the practical application of using a single perceptron for classification using iris dataset. Thank you all.